everyone, and we are from sub 7. We're going to present our journal revision report, and the title of the journal that we take is the Bioremediation of Heavy Metal by Growing Hyperaccumulator Endophytic Bacterium Bacillus SPL14. So this is our group member, and Vanessa, that is me, Jiawei, Saidah, and Renuga. So the content in our journal reflection report is summary, benefit, limitation, and the suggestion for the improvement in this research. So the summary of this research is heavy metal bioremediation by a metal-resistant endophytic bacteria L14 isolated from the cadmium hyperaccumulator Solanium nigrum L was characterized for its potential application in metal treatment. Heavy metal pollution by industrial activity and technological development is posing significant threat to the environment and public health because of its toxicity, non-biodegradability, and bioaccumulation. The mechanism study indicate that its remediation efficiency may be greatly promoted through inhibiting the activity of ATPase. In this study, endophytic bacteria L14, which was isolated from the leaf of cadmium hyperaccumulator Solanium nigrum L, has been chosen for the bioimitation of synthetic solution of cadmium, lead, and copper. So, the excellent adaptation of the ability and promising remediation efficiency strongly indicate the superiority of this endophyte in a heavy metal bioremediation at low concentration. This could be useful for developing efficient metal removal system.
These are the benefits of bioremediation of heavy metals. The bioremediation using the bacterial strain EBL14 creates high degree resistance to heavy metals such as copper-2, cadmium-2, and chromium-4. The growth efficiency in the presence of heavy metals rapidly increased. At lower concentration, the growth of the bacterial strain advanced with the heavy metals. The hormesis of EBL14 was directly forced by continuous usage of ATP energy. The efficiency of the remediation is greatly promoted through inhibiting the activities of ATPase. Next, the metal-resistant system in the bacteria is so powerful that it could balance with the import mechanisms during the process of bioremediation. Last but not least, the practical that carried out using in vivo removal and transformation of the heavy metals does not cause serious secondary pollution in bioremediation.
Next, for the limitation, there are some limitation of biodegradation using microbes, which are some microbial metabolites of contaminants may produce toxic metabolites. Next, it is time-consuming. Other than that, it is limited to those compounds which are biodegradable compound only. Next, intensive procedure which must be customized to the specific condition. As example, it has to do a manageable studies on a small scale first before applying on the actual scale. This is due to the highly specific of microbe population, which need to consider suitable growth condition and appropriate level of nutrients and contaminants.
There is few suggestions for improvement of the bioremediation. The first, more research must be carried out using specific strain of microorganisms for the different type of bioremediation. The second, environmental conditions must be studied well for the maximum efficiency of the bioremediation. Third, the genetic technology can be used to improve the efficiency of bioremediation of the microorganism. The final, bioabsorbent can be used to improve and help the further process.
In brief, low remediation efficiency and poor adaptation abilities to toxic materials are being overcome by the holistic characteristic of ABL14 carrier to inhabit the toxic niches and drive even more biomass under such tough conditions. As the result, it is not surprised that the microorganisms which not only possess heavy metal bioremediation ability but also shows the hormesis to the treatment of substrate will be more feasible for future practical applications. The majority removal and transmission of cadmium-2 and plumbum-2 ions by EBL14 were carried out in vivo, indicated that it will not cause seriously secondary pollution in bioremediation. That's all from us. Thank you.